Yes, 1 second, sir. We are live now, sir, in the YouTube.
Yeah.
Yeah, you can.
That in the YouTube window, I can see myself.
Yes, sir, but there will be a delay of 20-25 seconds, sir.
Yeah, that's right.
Right, sir. You can pause that YouTube thing, sir. Or else you can mute that YouTube video, sir. That way, no echo will not come, sir.
Yeah.
Right, sir.
I have paused and muted.
Right, sir. Okay, sir. Sure, sir. So I will mute myself and then I will stop my video, sir. In case of anything, you give tell me, sir.
Okay, fine.
Right, sir. Thank you, sir. Sir, one question in that Google response sheet, sir, by a student called Sri Venkatesh.
In the Google response sheet,
Yes.
where it is?
Okay, sir. I will just share you the link, sir. Just a second, sir. In the Zoom chat, I'm sharing you the link once again, sir. Can you click the link in the Google Zoom chat, sir?
In where?
Zoom chat, sir. Zoom chat.
Yeah, Zoom chat. There is to everyone you are giving from Murli Krishnan to everyone.
Yes, sir. That link.
That one?
Yes, sir. Yes, sir. That one, sir.
Okay. Yeah, right. It is there.
Yes, sir.
How shall I clarify the doubts that arise while revision of lecture materials? So this is the forum. This is the time that you can clarify. Okay. Just 1 minute. I'll just put it there. Okay. Yeah, so good evening, everybody. This is the live session of NPTEL Machining Science course. And this is in the life science, you can actually clarify all your doubts that you have with you and the difficulties that you have gone through while doing this course throughout the semester. Okay. You can write this in the chat box, or you can, speak and ask the questions. Mr. Sri Venkatesh, you are asking that how you can clarify the doubts. As I said, that you can actually put it in the chat box, or you can put it in the Google chat, or you can actually speak and clarify. All right. Okay. I got few of them, like Hari Pravan. You are asking how sharing happens after compression of workpiece with the tool. Is it similar to sharing in sheet metal forming, sir? Okay, shearing, it's actually metal deformation as well. All right, so as I said, that when the metal is deformed, there is a severe plastic deformation that is required for the metal to deform. All right, and in case of shearing, it's the same process that we have discussed for the plastic deformation of material. All right. Now, in case of sheet metal, that's also shearing. So this is also, the segregation of the material. All right. But here it is something from, I mean, as you are saying that, is it similar to shearing in sheet metal forming? It's not exactly this. All right. Now, when you are talking about the metal deformation, that means the metal segregation through the chips, I mean, in the form of the chips. In that case, what we are saying is the deformation of material which segregates a part of the metal from the from the workpiece. Okay, here in the case of shearing, what we are saying is that it's actually making two parts. All right, one sheet is divided into two. So that's not exactly the same thing. Now, okay. Yeah, Arun Narasian, do you have any question? Please ask. Good evening. Kindly post your doubts. Once again, we are requesting, kindly you can post your doubts. Now, Mr. Rohan Thomas, you are saying that depth of cut is equal to the uncut thickness, right, sir? Now, this is right in case of the orthogonal cutting. All right. If you now see the two schematic diagrams of orthogonal cutting and the oblique cutting, you will see that the depth of cut is taken as the uncut thickness in case of orthogonal cutting only. In case of oblique cutting, it is not the same. Okay. So how it is different, that you can find out. We have already done that in the analysis. All right. So they are not the same in case of the oblique cutting, but it's same in case of orthogonal cutting. Okay, so any more question, please? So I'm waiting for your post. So if you have any doubt, any question, you can ask here. We can discuss it. All right. Rohan Thomas, you are saying that then in assignment 3, question 5, depth of cut is also the answer. Yes, sir. Yeah, if it is for orthogonal cutting, obviously this is the same. Yes, if it is for orthogonal cutting. I don't remember what is there in assignment 3, question 5 exactly, but you can see whether it is for the orthogonal cutting or the oblique cutting. If it is for orthogonal cutting, it is. What you are writing is right. What you are saying is right. Mr. Arun Narasian, you are saying, tell about single point cutting tool. Wow. So about single point cutting tool, we have discussed in great details. Okay, let me also discuss something here. Single point cutting tool, first of all, it has one cutting edge. Okay, one cutting point. Okay, so it has 6 angles. All right. two rake angles, two the flank angles, and two end cutting edge angles. Okay, those we have discussed. And now the tool specification, I mean, how the angles are given, as I discussed in my lectures, that there are different kind of nomenclatures. Okay, and different countries opted for different nomenclatures. Like we have the coordinate system opted by United States. Okay, in India and the East European countries and many European countries, there is an orthogonal rake system. Okay, there the tool nomenclature is different from the coordinate systems or ASA system. And there is a normal rake system. So normal rake system we also call as the international system, because now all the countries are trying to adopt that. That's about the single point cutting tool. Now, many things have been told about the effect of these angles on the power consumption or the force. For example, that what happens if the rake angle is changed. All right. So if the rake angle is increased, for example, then the tool is becoming thinner, right? And once the tool is becoming thinner, in that case, the tool strength becomes less. Okay, and also once the tool is becoming thinner, in that case, the material available for the heat conduction will be less. So more heat accumulation will be there, and the tool wear will be more. I mean, tool life will be less, sorry, tool life will be less, okay? And so on. There are other effects of the other angles that you can see in the slides that we have discussed in the lectures, okay? Okay, then Mr. Rohan Thomas, grinding. What is exactly that you are asking? I didn't get it. From which book we can expect questions from the exam? Questions you can in the exam you can expect from my mind. I mean, I don't take it from the books exactly. I create those questions. Most of the questions are created. And if you go through the lecture material that we have discussed and the material that you have been given as the handouts, if we go through that, you will be able to answer to these questions. There will be no tricks, no hidden difficulty. You will be able to answer them, and there's no then they are not difficult questions, I can assure you. All right. So don't expect that I will give these questions exactly from some book. So you have to read all of them, all these books. No, not like that. Basically, you have to clarify your basics, okay, fundamentals. Mr. Narasayan, I hope you understood what I discussed about the single point cutting tool. Okay, so rest of it you can also look at the lecture material, as I said. Mr. Rohan Thomas, can you post some more practice questions? Now, see, by practice questions, I mean two types of practice questions are there. One is a theoretical, that means the objective type theoretical. Okay, like what happens to the cutting force if the rake angle is increased. Okay, it will be decreased, increased, or no change, or none of them. It's like this. Another set of questions is the numerical questions. So those numerical questions I have discussed quite a few of them after few topics. So you can see them. Additionally, you can see any book, any metal cutting book, that is a lot of them are available by Indian writers, by foreign writers, okay, available in India in the low prices and so on. So you can see in any of these books, those workout questions are there, then the exercises are there, so you can see from there. Okay, those will be the practice questions. Now there are many practice questions also in the books, like I have given you some reference books, name of some reference book. I hope I have given you that book, which is the Groover, Okay, Michael Gruber book. It has the machining section. In the machining section, you can find the practice questions as well. Okay, or as a matter of fact, you go through any of the metal cutting books, you will find a lot of practice questions. Okay, and in the lecture material itself, I have discussed many numericals that you can go through. And as Mr. Murali Krishnan has reminded in the chat, there are self-assessment questions also there, okay, below the lectures. So you can check them. They are simple questions. So you can test yourself that whether you are able to answer to these questions. If not, then you go through the material and then come back to those assessment questions and answer to them, okay. But overall, I'm telling you that in the exam, the questions will not be difficult questions. They will not be tricky questions. They will be within the material that I have discussed in the lecture classes. And once again, I'm repeating that if you are going through the lecture material well, in that case, you will not have any difficulty in answering those questions. Okay. Mr. Rohan Thomas, thank you very much for attending the course, and I hope you have enjoyed it. In case you have any more questions, you can still ask and we can discuss it, okay? You are asking something about grinding, Thomas. What is that exactly? Tell me. You have any exact doubt or question on grinding? Grinding is a very important topic, you know, and it is different from the normal cutting because it has multiple edges, cutting edges, right? Okay, Rohan is asking to Murali, Mr. Murali, that when we'll get the hall ticket. So he will answer you. Yeah. So in grinding, Mr. Thomas, I have discussed grinding in great details, in fact. So you can go through my slides, okay, lecture material that I have discussed. And in case any doubt comes, so you can post it in the course discussion also, okay. So there I will, and I will reply to those questions. Question 5 was about grinding. What is that question? Can you tell me? At high speed, Mr. Hari Pavan is asking, sir, at high speed, why most of it is taken by chips only? Because the chip flows away, right? And the heat which is conducted to the chip, it goes away from the tool and the workpiece. So therefore, it is going out, and most of the heat is going to the chips because it is because of the plastic deformation and the friction between the rake face of the tool and the chips. So there the heat is produced, and that heat goes with the chip and goes away. Okay. So just imagine that most of the heat is formed when the chip started forming. Okay, that is the plastic after the plastic deformation, and then some additional heat is added to this chip when it is getting when there is a friction between when chip slides along the rake face of the tool. Okay, so the chip is getting heated up and then it is segregated, so it is going out. Okay, it's flowing out. Okay, Rohan Thomas asking for reducing surface roughness in grinding process. The grinding condition should be chosen to reduce the value of. You find out from there. Okay, I'm not telling you the answer. The answer is in the slide in sufficient details. Mr. Thomas, go back to the slide. I'm not really. I will not discuss it here because in that case it will be kind of a spoon feeding, and that I don't want to do. I want you to work some way. Just please go back to that surface roughness in grinding. Okay, that chapter. I have discussed it in great details. Mr. Narasian, your main doubt is single point cutting tool rake angle is increase or decrease. Any changes according depth of cut is Mr. Narasian, I'm not very clear about this. Once again, I will read that. Main doubt is in single point cutting tool, rake angle is increase or decrease. Any change according depth of cut. Well, first of all, let me tell you that if in a single point cutting tool, if the rake angle is changed, it has nothing to do with the depth of cut. Okay, first of all, depth of cut is being constant. Suppose you are giving the depth of cut as 2 millimeters. Okay, then you are taking two kind of tools with the same depth of cut, 2 millimeter. One rake angle is 10 degree, one rake angle is 15 degree. So once you are increasing the rake angle with a constant depth of cut, in that case, the tool is getting thinner, tool is becoming weaker, and less material will be available for the heat conduction. So these are the effects. So tool life will be less, okay, because tool will be thermally deformed, more heat accumulation will be there, and so on. Mr. Vishal Rathore is asking, can you ask about milling process plans operation sheet, sir? What I don't understand what is milling process plans operation sheet. Can you please clarify what is that exactly you're asking, Mr. Rathore? How to write milling process plans operation sheet. Sorry, Mr. Rathore, if you can clarify your question, it's not very clear. What exactly you are asking in milling? About milling process plans operation. No, it's not very clear, Mr. Rathore. Can you clarify your question? How to write what exactly? Yeah, Mr. Rathore, I'm waiting for your question. How to write what exactly for milling? Milling machine process plan. No, we have not discussed process plan or something. That's another topic. So we discussed about the milling process, not the milling machine. Okay. Now, Mr. Venkatesh, you are asking blue or pattern of final assessment. Blue or pattern of final assessment. I think about the final assessment, more light can be thrown by Mr. Murali Krishnan. So he will clarify this, okay? Pattern of, well, are you asking about the pattern of the final exam or pattern of the final this thing? How this assessment is made? If you are asking about the pattern of the final exam will be on the, there will be two types of questions. One will be the, the objective, all will be objective type. And one type of questions will be, as I said, that multiple choice, A, B, C, D, you have to select one of them, okay? And there will be options given for that question. And another type of questions will be the numerical. That means a numerical problem will be there and you have to solve that. And you have to actually write the answer there, okay? So for writing the answer, you will be given the keyboard and all. I mean, you have to click it or keyboard, mouse or keyboard. That system you will find out in the lecture itself. That is a pattern of question. Now, Mr. Murali Krishnan has answered what will be the pattern of the, what will be the pattern of assessment. Okay, like 25% of assignment, 75% from the exam, that will be considered for the final exam score. Okay, that's what probably Mr. Venkatesh, if you're asking. Okay, any more question? Mr. Haripavan is asking how cutting force is related to built-up edge formation. Like, is it decreases or increases? Well, see, when the built-up edge is formed, I have given you conditions for the built-up edge formation. All right, what are the conditions that you can see in one of the slides. Now, the cutting force will be depending on how the rake angle is changing. All right. So when the built-up edge is formed, built-up edge is a dynamic affair, meaning that it is forming and then it is breaking, okay, and vanishing, as I discussed, and therefore the rake angle is changing. That I also said during my lecture discussion. The rake angle changes depending on the formation of the built-up edge, whether it is growing, when it is breaking up, and so on. So if the rake angle is decreasing, in that case, tool is becoming fatter. Okay, tool is becoming fat means tool strength is more. All right, and more heat will be conducted because there will be more material available for the heat conduction and so on. Okay, so it's a dynamic affair, and on the cutting force, it does not have much effect of the built-up edge. That means built-up edge will not have the effect on the cutting force. On the cutting force, the major effect will be of the rake angle. Okay, as the rake angle is changing, the cutting force and the cutting power will be changed. Okay. You see, I have given you a curve that as the rake angle is decreasing, okay, as the rake angle is decreasing, the cutting force, just 1 minute. You can see that curve. I can actually, all right, I will just tell you that as this rake angle is increasing, the cutting force is decreasing. That is the inverse way it is affected. Okay. So if the rake angle is changing, whenever there is a built-up edge formation, if the rake angle is increasing, in that case, the cutting force will decrease, and vice versa. That curve you can see from one of my lecture slides. All right. But mind one thing: the BUE formation is a dynamic process. Okay, every time the BUE is changing, the volume of the built-up edge, the geometry of the built-up edge is changing. That means the rake angle is changing. Okay, very dynamically. It is increasing and decreasing, increasing and decreasing. So each time it is rake angle is increasing, the cutting force falls. And if it is decreasing, cutting force increases, and so on. From merchant circle, cutting force decreases with increasing rake angle. That's right. You are right. Okay. I also discussed that why what is the reason if the rake angle is increasing, why the cutting force falls. I discussed that phenomenon also. Okay. Now, Mr. Venkatesh, you are asking, will we be allowed to use calculator to solve numerical problems in final exam? There will be a calculator given in the soft form. Okay. Calculator will be available. You will not be able to use your own calculator, most probably. There will be calculator embedded in the screen. Okay, so you can use that. Okay, so once again, I'll tell you that The exam, you don't have to worry about the exam. It will be simple. Questions will be simple, and you will be able to answer them if you go through the material well. All right. I once again thank you for attending the course. I hope you have enjoyed. And if you have any more question, you can put it on the forum, and I will reply to those questions. Okay. Tell about spark erosion machining material used for die sinking. Mr. Arun Narasyan, I have not discussed. This is not the material of the machining science, all right? And therefore, the spark erosion machining I have not discussed. It comes under the unconventional machining. Okay. So thank you. Thank all of you for your attention, for attending the course. And I wish all of you good luck and having a good time. Thank you very much.
Thank you so much, sir, for your valuable time. I'm going to stop the broadcast now and let's
Sure.
join the next session, sir.
Okay. Okay.
Bye, sir.
Okay.